So today we are seeing nomenclatures of organic compounds. First of all, we have initially organic compounds are named on the basis of source from which they are obtained. Okay, some typical compounds in which common and trivial names are also differ. Okay, so here we have trivial names, derived name, and IUPAC system names. Okay, so here compound, this is methanol. Its trivial name is wood spirit or methyl spirit, obtained from destructive distillation of wood. This is urea, obtained from urine. This is methane from marsh gas. It was produced in marshy places. This is carboxylic acid, acetic acid produced. Trivial name is vinegar, obtained from acetum, that is vinegar. And this is dicarboxylic acid, that is oxalic acid, obtained from oxalis plants. This is formic acid, obtained from formaces or red ants. Okay, this is lactic acid, obtained from sour mild. And these are malic acid, obtained from apples. Remember these structures as well. This is butyric acid, obtained from butter. This is caproic acid, obtained from gourd. Okay, these are some important, very important organic compounds which you might see in most of the questions in the exam. What are derived systems? According to this system, any compound is given name according to the pair name to the homologous series. So this is alkane, derived name methane, alkene, ethylene, alkyne, acetylene, and alkanol, carbinol, alkanal, acetaldehyde. This will help out in naming the compounds. Okay, IUPAC names. Okay, International Union of Pure and Applied Chemistry. IUPAC system for naming in something is very similar to addressing a person with his complete designation or name. Okay, according to this, organic compounds have some standard process, may be called naming method, in which anything about naming molecule is in a systematic way. Okay, so here is some prefix. Dr. Abdul Kalam, the doctor is prefix, main name is this, and this is surname. Okay, systemic IUPAC names follows S, P, W, P, S. What is S? Secondary prefix. P is primary prefix. W is word root, and P is primary suffix, and S is secondary suffix. So here are definitions. This is what is secondary prefix. It defines substituent and position of a substituent. So here we have alkyl R group CH3. This is methyl, and if 2 carbons, this is ethyl, and 3 carbons propyl, 4 carbons butyl, and if phenyl is attached, phenyl group is attached, then it is called as phenyl. Okay, if OR group or alkoxy group is attached. Okay, we write methoxy for 1 carbon, and ethoxy for 2 carbons, propoxy, and phenoxy for phenyl. Okay, and for halogens we use chloro, bromo, and iodo. For NO2 we use nitro, for NO we use nitroso, and for N3 we use azido. Okay, remember these prefixes. Okay, what are primary prefixes? They are basically a primary prefix used simply distinguish between a cyclic from a alicyclic compound. A primary prefix cyclo used immediately before the word root. It defines nature of parent carbon chain: open chain, closed chain, cyclo, bicyclic, bicyclo, subcyprine, and is pyro. This is pyro. Okay, word root. What is word root? Basic unit of the name. It denotes the number of carbon atoms present in the principal or longest possible chain. Okay, according to the number of carbon in parent chain: C1 meth, C2 eth, C3 prop, C4 but, C5 pent, C6 hex, hept, oct, non, dac, undac, dodac, tridac, and equus, and hectac, and so on. Okay, primary prefix is always added to the word root to indicate whether the carbon chain is saturated or unsaturated. 3 basic primary suffixes are given below. You can see here saturated for ane for alkane, ene for alkene, and ine for alkyne. Okay, yeah, see here compounds are given here. You can see here this is prop, word root, and ane is its suffix, that is primary, no secondary suffix, no prefixes. Okay, this is only propane. And here we have propene, here we have propine, here we have ethine. Okay, here we have cyclic compound, that is prefix number primary prefix is cyclo, word root is but, because it is 4 corner compound. okay, and primary suffix is "-ene". So the IUPAC name will be cyclobutane. For this one we will use cyclobute, and there is, you can see here, one double bond is present, so we use "-ene" as the primary suffix, and the compound IUPAC name is cyclobutane. For and this here you can see here is one triple bond, so is cyclo, and this is 8 carbon ring, so we use oct, and primary suffix is -ine because of the triple bond, and the IUPAC name is cyclooctane. Okay, alright. Type of carbon chain: unsaturated with one double bond, diene, alkadiene. Okay, unsaturated with one triple bond, diene or alkadiene. Okay. So secondary suffixes are given here: alcohols, OH, aldehyde, CHO, ketones. We studied these functional groups previously in previous topic class. Okay. Pause the video if you want to review this again. Okay. Steps in naming IUPAC: name, selection of parent chain, numbering at parent chain. Okay, select the longest carbon chain containing maximum number of carbon, and this longest chain is also a parent carbon chain. Longest carbon chain not always straight, it may be branched, or you can say it may be curved, or you can say or another shape. Okay, first you can see here, not straight chain, maybe a straight chain, but here the longest chain is not straight. Okay, if two or more carbon chains contain same number of carbon, then the parent carbon chain is considered which has more number of substituents. You can see here we have, in this one we have 1, 2 and 3 substituents, and here we have only one substituent. Okay, so which have more substituent is considered the parent carbon chain. Okay, numbering of parent carbon chain is done by lowest loctant rule. What is lowest loctant rule? According to this rule, numbering is done in such a way so that substituent will get the lowest number. We have to see substituent will get a lowest number. You can see here, if we start numbering from this side, 1, 2, 3 and 4, the methyl on carbon, this carbon will get 3 number. Okay, but if we count from this side, 1, 2, 3, 4, it will get 2. Okay, it will get 2. So the lowest number is preferred. Okay, so we will count the chain from this side. Okay, so this is 2-methyl butane. Okay, IUPAC name, numbers of substituents will be separated by commas, and number of alphabet is separated by hyphen. Okay, if 2 or more different substituents are present at carbon chain, the numbering is done according to the lowest locant rule. By writing IUPAC name, follow alphabetical. We number according to the lowest locant rule, but while writing we write the lowest alphabet first. As you can see, ethyl is ethyl in ethyl is like comes before M in alphabetic order, so we write ethyl first. But when we are selecting the longest chain, we will number from that side in which the lowest locant will get the lowest number. Okay, so methyl will have to take the lowest number, so we will start numbering from here, 1, 2, 3, 4, 5, 6. So it will be written like 3 ethyl because in alphabetic order E is before M, so 3 ethyl 2 methyl hexane. Okay, rule number 5: if 2 or more similar substituents are present, we use di, tri, tetra and so on. Okay, you can see here at carbon number 3, 2 methyl groups are attached, so we will name this 3,3-dimethyl heptane. Okay, and this is, we number from this side 1, 2, 3 because if we number from this side, the you can say substituents are 4 and 5, but we have to make sure that the substituents get the lowest possible number in the chain. Okay, so we will start numbering from this side, and it will be 3,4-dimethyl heptane. And for this we will start numbering from the right side. Okay, and here we have 2 methyls and 1 ethyl. Okay, so ethyl is written first when we are giving the name Okay, so it is 3-ethyl 3,4-dimethyl heptane. Okay. Rule number 6: if two or more substituents are present on parent carbon chain and they get the same number from either side during numbering, then numbering is done by alphabetic order. As B comes before C, so we will start numbering from this side. So bromo gets the lowest possible number first, and chlorine gets the next possible number. Okay, so this is 2 bromo and 3 chlorobutane. Okay, so here are some structures here. Write their names on your register, and pause the video, and after solving these check out the answers. Okay, here are the answers, you can see. Okay, I hope you did well. Okay, nomenclature of cyclic alkanes. We will start numbering from where the substituent is attached. We start numbering from that part. Okay, from 1 2 3 4 5 6. So this is 1-methyl cyclohexane. Okay, or we can write simply methyl cyclohexane. Okay, yeah. Now this is alkene alkyne. First example is here. First of all, see the rules. Select the longest chain containing the maximum number of multiple bonds. If two chains have same number of multiple bonds, then check maximum number of carbon to select the parent carbon chain. If multiple bonds and carbon atoms both are same, then maximum number of substituents to select parent chain. Number of multiple bond is greater than number of carbon is greater than the number of substituent priority. Okay, here we can see if we select the highest possible chain, that is 1 2 3 4 5 6 7 8, but in this chain this double bond is missing, so we will select that chain which contains all the multiple bonds. Okay, so we will select this chain that is that is 5 carbon. So this is the substituent here. Okay, and substituent here as well. So this is the longest chain, that is 5 carbon, and here you have 6 carbon longest chain, and here you have 5 carbon longest chain. But here you can see this is missing. Okay, this is missing. You can select this chain as well or this chain as well, because both chain contains equal numbers of multiple bonds. Okay, don't confuse. Okay, numbering of parent carbon chain. While doing numbering in alkene and alkyne, minimum number should be given to multiple bonds. If multiple bonds getting same number from either side, then give minimum number to substituent. Okay, in alkenes and alkynes, multiple bonds are preferred first in place of the substituents. Okay, for numbering, multiple bonds priority is higher compared to substituents. Okay, so here are some examples here. You can see here. If you have any confusion in this examples, let me know in the comment section. Okay, for more than one multiple bonds, use di, tri, tetra, and so on. So here you can see here, this is structure, skeletal structure. So here you can numbering 1 2 3 4 5 6 7 from this side, because the double bond will get the lowest possible number. Okay, so this is 7 carbon heptane. So we will write this hepta 1 double bond is at 1, and 3 hepta 1 3 di because of 2 double bonds, and ene for alkenes. Okay, and here you have 2 double bonds as well. You will write it penta 1 4 diene. Okay, rule number 4: if in carbon chain alkene and alkyne both are present at the same position from either side, then numbering is start from the alkene side, because alphabetically E is before Y. E is before Y. So alphabetically order according this will be preferred, and numbering start from the that side where alkene is present. Okay, you can see examples here. This is present at this carbon, and double bond is present at this carbon. We start numbering from this side as ene in alphabetic order. Okay, here then 1. Okay, so we will write this pent 1 ene and 4 ine. Okay, and hep 2 ene and 5 ine for this one. Okay, some questions here. Solve them and check out the answers. Okay, all right. This is cyclic alkene structure. Okay, some examples are also here as well. So this is for the topic I hope you understand the functional groups uh, and the structural formulas, dot line formulas, and scalar formulas, and also now you have learned the nomenclatures of alkenes, and alkynes. Okay, so this is for the topic. Good luck for the exams.